Alrighty. I think we're pretty good here. Happy Wednesday. Today, don't forget, is the first day of lab. So I believe Mr. Dia had everything set up in the lab section in Canvas that I don't have access to. I wish we just were all in one section, but I don't get to make the rules, unfortunately. So it should all be in the CIS 200L section for you there. And then basically at the end, he's just going to tell me what your overall lab score was, and that will get thrown into this grade lab placeholder here for your final score for the class, if that makes sense. So whatever, like 98%, you'll get 98 points. And hopefully that'll be relatively easy. And that, again, that makes up 20% of your overall score in the class. Really, it's like participation points, right? You show up, you put the work in, you'll get the labs done. Pretty much can guarantee it. I have had cases where students just don't seem to be able to do the labs, and we have to do some additional work and some tutoring and some other stuff. But basically, if you show up, you're going to get them done, right? So that should go relatively well for you. And honestly, the only way to get better at writing code is by writing code. You can read about it all you want, but until you actually go and write some code, it's going to help a little bit. Not to say there's no value in textbooks or anything, but you get better by doing. So the focus of these labs is every week you're doing, and then we'll have projects. Pretty much every week you'll have something to work on unless you work ahead. Whereas every other week we'll have a project for you to be working on. And if you plan out your time well and split things up, and I'm sure you all have lives and other classes and things that have their own projects. So, if you want to work ahead, great. If you want to leave it for the last week, great. It's totally up to you. But you always have something to be working on code-wise. That should be a lot of fun. I did post the syllabus quiz a little later on Wednesday, so let's do 11:59 p.m. tonight. If you haven't had a chance to take that one yet, more free points. Just make sure you understand what's happening in the course. And then a question having you plan out your time. So one of the things that's very, very useful is to be very intentional about your time, right? For any college course, the typical rule of thumb is that it takes 2 hours of work outside the class for every hour in the class. I don't know who came up with it, but that's what we've been working with for as long as I can tell. So I ask you, please plan your time. Tell me what other 8 hours you're going to spend on the class and put it in your calendar. And then if you don't use it, great. You get stuff done early, fantastic. But that way it's in your calendar, you got it blocked out, you're being intentional about it. You're much more likely to be successful if you say, hey, this is the time I will do the work, rather than, oh, I'll get to it when I get to it. And honestly, that's how a lot of people work, and that's okay. Like that is real life. And if the deadline isn't for 2 weeks, we don't always work ahead. But if you do work ahead, you'll be more successful. And it's much easier for me to help you as well if you are working ahead and get stuck on something. So I forgot to pull up chat on the other screen here. Let's see. All right. Okay, cool. I know at least one person was going to join us remote because they are ill, which is fantastic. Don't come if you're ill, please. Just don't be here, okay? We've got options. And again, if you're ill and don't want to join the live stream, just watch the recording. That's cool too. Being sick takes a lot of work. So if you're not up for it, that's okay. I'm not taking attendance. I trust you folks are adults and can figure out how to manage your own class schedules and keep up with the work. So that's generally how that one goes. All right, so that's for the syllabus quiz. Don't forget to take that. And then starting this week, we'll have actual chapter quizzes on the material, just one per week, not one per chapter, because that's just kind of annoying. Well, that's neat. Try again. Okay, so later is I just have to hit refresh. That's good. So this week we're going to do review. I'm hoping it's mostly review on objects and classes, and then I want to show you some new stuff if we have time. If not, exceptions won't take the whole time on Monday, so we can get to that new stuff then if we don't get to it today. But you all covered classes in 150. I think, okay, most people are nodding. Okay, did you write any code with classes, or did you just talk about classes? You wrote some code? Okay. What did you do with classes? Anything interesting at all? You wrote a class for what?
I was just a project about an airline at sea.
Okay. So your class was the plane and it had a bunch of seats inside of it? Okay, cool. Anyone else do anything different? Maybe you wrote a class? Okay, all right, so definitely we'll need some practice on it then, if that was the only thing we've done. So most of the world nowadays utilizes objects and classes because object-oriented programming makes sense to people. And really, that's why we use it. The computer could care less. C++ does not care if you use classes or not. You could put everything in a main and have your functions in main, and we could make do. You could make your functions take like 50 gazillion different parameters, and you could pass around 50 different attributes every time you wanted to talk about a plane, rather than a plane object or class that has attributes for the model number and the type of plane it is and how many engines it has and the pilot's name. I don't anything you want to have about planes. We could do that. Thanks, Delician. I'm terrible with names. Please correct me. I want to get them right. It just takes me a little bit of practice. So we barely did them in my 150. Okay, it's something supposed to be done in 150, but not necessarily super deep. So don't feel bad if you haven't done a lot. We are going to go deep into classes and have lots of practice on them. And our first project, starting next week, once we talk about exceptions and pointers, will actually be using classes and exceptions and pointers, that sort of thing. Back to my friend. Thank you so much for donating some bits to the Student Scholarship Fund here at the College of Engineering and Computer Science at U of M Dearborn. That is so awesome. We just keep racking up ad money. Thanks for tolerating the ads if you watch the stuff on Twitch. They go to a good cause, and our friends donating bits. That's super cool. And Twitch now is paying out every $50 instead of every $100, which is cool. So like we don't get more money, but like we get it faster. So that's kind of fun. And then there is like a Giving Blue Day, and they had some sort of challenge. I don't know if we actually got any prizes or anything like that, but on Giving Blue Day, they give out additional prizes for fundraising on that day. So that's always fun. All right, let me start up Visual Studio here. And let's start a new project. This is officially week 2. So is it helpful if I name them by week or by topic? What's going to make the most sense? Like if you wanted to go back and look at the code, which it's okay if you don't. By topic? Okay, so I'll call this like classes or objects and classes. I gotcha. So we'll do an empty C++ project. Just objects and classes here in my public repository. Again, this one's out here. It's just a public repository, so that way I don't have to give all of you access. I'm not doing anything super interesting, so I'm fine making it public because that just makes my life easier. When you folks have repositories, they will be private repositories because the GitHub Classroom integration does it for you. I generate a link, you click the link, it makes you a repository that you have access to, I have access to, and Mr. Dia has access to, which is nice. That way he can actually score your lab assignments, and life will be good. So, and because it's private then, no one else in the class will be able to go peek at your code, which is good. You don't want other people cheating off of you, right? We had that talk last week. Yeah, okay. All right, so let me make the project. And then in my GitHub client here, it should say, hey, there's a bunch of new stuff, right? So let me go find my 200 folder. I get a bunch of repositories, don't worry about it. So there's an SLN file, that's a Visual Studio Solution file. There's a VCX proj, that's my Visual Studio C++, I don't know why there's an X there, project file. Sure. And then there's the VCXproj.filters. This is just an additional Visual Studio file. If it changes, it changes. Let it be. It's okay. No big deal. Well, there's no code yet. Well, it's okay. We haven't made any code yet. We made an empty project. So I'm going to go to my source files. I'm going to add a new item. And main or source.cpp is fine here. Again, if we want, we could do our little hello world example, but we probably don't need too much here. Let's have an int for main. Do all these. So using namespace standard and include IOStream. Really shouldn't have this stuff memorized, but that's okay. You're welcome to just copy paste that sort of stuff. I don't expect you to have it memorized. I just want to make sure it runs. I always like to make sure it runs and compiles. And we get hello world. Fantastic. So now we should see there's a source CPP file. Yay, we have our C++ code file. So we've got everything in the right place. We found the files. We can make a commit. That's the snapshot. It saves the state of that folder at that point in time. Once we've got that commit, it's really, really, really hard to lose. Okay, so I recommend you commit early and often. Now, you don't need to like interrupt what you're doing to make your commits, but like when you're taking a quick break, go for it. Just make a commit, right? Go get your coffee refill, make a commit. You don't have to do it every 10 minutes. I mean, as much as you want. They're essentially free. There is a slight little cost to send bits across the internet, right, power-wise, but we don't really care about that because in the grand scheme of things, Bitcoin uses way more power than we're going to with Git. So don't worry about it. You don't have to sweat it. Other people do worse things. So it's okay. All right. And so we'll call this, I don't know, project started. Here, just give it a commit. Now, my computer knows about it. But notice now I have a push button. The central repository, the origin or the cloud repository on github.com does not know about it. That's when it's a little bit risky because only my computer has it. So right now, if my toddler walked over and dumped my coffee cup on my laptop, which has happened before, it's really sad, I might lose that commit, right? But once I push out to the cloud, GitHub makes their money managing people's code in the cloud, right? They're probably not going to lose it, right? I can pretty much guarantee they won't lose it because they would lose business, right? That's bad for business to lose people's code. It makes people really sad. Okay, so once we've got it, if you want to double check, right, and it's always good to double check, and before you turn stuff in, you can go make sure you can see it on the website, because if you can see it on the website, I can see it on the website, right? If you can't see it on the website, don't turn it in because I can't see it either, right? That's your last sanity check here. So we'll take a look. I can click on the folders, and it will just show me what's inside the folders. Again, there's another folder. Depending if you check that box or not, you can have solutions and projects in different folders. I like the different folders for projects because I've been doing this for a long time and it makes me happy. It doesn't really matter. Inside of that, now I see my source CPP file. I can click on that, open it up, and it looks like I have Hello World. Again, nothing interesting yet, but it made it. So we've synchronized now. My computer's in sync with the cloud. Life is good. If you ever want to double check, just click this little fetch button here. It's going to go think and say, hey, am I in sync? And if you don't get a push or pull option, you're in sync, right? Everything your computer has, the cloud has. Life is good. All right, so now we can actually go back and do something. So two ways of going about making classes. I'm going to take the lazy approach because I promise you it'll be easier later for what we're going to do. Okay, if when you go out in the workplace and they say do it a different way, just smile and nod, they sign your paycheck. Go for it, right? You don't have to take the lazy approach. And again, it's a little lazy. So I'm going to make a header file. Remember, our header files essentially get to define the class. And if we want, they can just say, here's a function named this. I'm going to do all the code in the header file because it makes my life easier on the next thing I'm going to show you. Some people say that's bad, and sure, I just smile and nod. That's okay. They're welcome to criticize me all they want. In the scheme of things, it really doesn't matter for our purposes. Now, when you get to something that happens at like millions and billions of scale, yes, those little performance boosts that you can get by putting things in the right place, those do matter. For what we're doing in CIS 200, it's your second semester coding. No one cares if it runs like 5 milliseconds faster. I promise you, I don't care. Okay, if you care, great, you can do the right thing, but this will make our life easier. So I'm going to make a header file here, and we'll call this one. So you already did a plain example. How about we do how about a cup example? Because I have my coffee cup here, and I'm very excited about coffee. Now, in Visual Studio, you'll get this pragma once thing. If you're not using Visual Studio, you might get the if end diff, if not defined, define, and then end if not defined nonsense. This is way easier and I like it. But if you're using Mac, that's fine. It should still generate all that stuff for you. It's okay. The idea with that is when this file gets used somewhere else, you don't want it to load more than once. Right? C++ does a bunch of really cool things when you start using other libraries and other files and other classes where it will go and load them. If you load it more than once, bad stuff can happen. Not all the time, but there's a chance bad stuff will happen. So we're just going to say, just load once, please. So just leave that alone there, here. And then we can define our class. So we can have our class for this is cup here. Right, class for cup. Then I have my private attributes, and then I have my public methods. You could also have private methods or private functions. Those are very helpful. Those are your helper functions where we don't want to let other people use them. They're just to make my life easier in the class code. Perfectly fine. But for now, our basic example, right? We have our private section, we have our public section. So things about cup. What does cup know about itself? Now, we also are going to need to include string. Let's use string here because I want to use a string attribute for some of these things. So the cup itself, right, is the broad general noun. When we write classes, they're generally nouns. They don't have to be, but most of the time they're nouns. And what we get in this attribute list is things about the noun, right? So when I say cup, you know not all cups look like this, right? Cup is just a concept, it's just a noun, and different cups will have different colors, different sizes, different shapes. They might have lids, they might not have lids, they might have handles, they might not have handles. They might have different amounts of liquid inside of them, right? And if you run out of bowls and you need to eat mac and cheese late at night, you might put mac and cheese in a cup. I've done it before. It's okay. You don't have to feel bad about yourself. You can eat mac and cheese out of a cup. It works perfectly fine, right? I don't know why people think you can only eat mac and cheese out of a bowl. And they look down at us who use our cups and our mugs to eat mac and cheese or ramen noodles. They work really well in nice mugs too. But that has some sort of contents, right? So these private attributes are things about the noun. So I might have a string for the color, maybe. I might have, is that lowercase s? I can never remember. No? Uppercase s string. Why does it not like me today?
The standard name, please.
Thank you, thank you, thank you. Using space standard. Yes. Lowercase s string. These are the things that are not worth memorizing. And it's different in different languages, and it drives me nuts. But that's okay. All right, so a string for the color, we might have probably an integer value here for, this will be my max volume. And then anytime you're dealing with units of measure, you should include what you're measuring. If I just say volume, some people might say ounces if you use the terrible imperial system. Some people might say milliliters if you use the better metric system, which is clearly superior. Other people might think you just want liters because they don't know how big it is, right? And I could say, hey, it's a half a liter mug, because that's easier than saying it's a 500 milliliter mug. Doesn't really matter, right? So whatever unit we want to measure with, I'm going to say this is max volume in milliliters. And I do this to myself every time, and I hate typing out milliliters because I usually misspell it, but it's probably close enough. So I know what's the max volume in milliliters I can put in here. And I might have an int for the current volume of contents or something, I don't know, in milliliters. And you might say that's a really long variable name, and I'll say, yeah, it is, but you know what it means, right? This idea that the code is for people who read your code. C++ doesn't care if this is X. It will work perfectly fine if it's X, or if it's current volume of contents in milliliters. C++ doesn't care at all. Who cares is people, right? People are going to read our code, so we want our variable names to be descriptive. We want to know what the variable reference is. You've done a bad thing if you have to put a comment in here and say X is the current volume of contents in milliliters, or what, something like that, and you have a variable X. If you have to leave a comment and tell me what your variable is, you've done a bad thing, right? Because you could have just named your variable better, right? So this whole idea that you need to tell someone what your variable is silly. We'll just name our variable better, okay? So we know what that is. And then we might have, how about a Boolean for has lid, right? That'll either be true or false, whether or not there's a lid for this. Maybe we can add another Boolean for has handle, maybe, because not all mugs have handles. Some cups have handles, some cups don't have handles. Although apparently the difference between a cup and a mug is the handle. It's not really a mug if it doesn't have a handle, but I don't know. I feel like that's a little bit discriminatory to the cups and the mugs. And why can't a mug be a cup if it has a handle? And just let it be a handle, or let it be a mug. All right. Other things about it here, we probably have a string for the contents, right? What is inside of it. So we can tell what the contents are, we can tell what the color is, we can tell how much can go in it, how much it currently has in it, whether or not it has a lid, whether or not it has a handle, any other things about a cup. So if I say the word cup to you, what other attributes might you think about a cup? Or if you have a particular cup in mind, yeah.
What it's made out of.
What it's made out of. Okay, so the string for the type of material, maybe? Is that a good variable name for it? Sure. Type of material made from? I don't know. Sure. We can make these as long as we want. And if you're using Visual Studio or any good IDE, you don't have to type all these letters. So just because it's a long variable name doesn't actually make it any slower for you to work with it in code because you have IntelliSense or type ahead, right? If I start writing some sort of method or function that needs to use this variable name, I start typing a couple letters here and it shows up for me, right? Okay, so it's not hard, I promise. All right, are we good for cup then? This is enough attributes for now. All right, let's see. Do I get, where's my, don't have the code generation, do I? This is the community edition. That's unfortunate. No. So other tools will write these functions for you, and it's really sad that this one doesn't, but it's okay. We can write our own. So these are private attributes. No one has access to them outside of the class for cup. Right? So if we want someone to have access to the values here, we need to give them a public method or public function that they can call that gives them access to it. Right? That's the proper object-oriented approach. We're following good habits of encapsulation. Right? We're taking all the details about a noun, putting them into one nice little package, and this idea of abstraction, where you get to work with an abstract interface or an API here, where you have public methods and you don't actually know any of the details. So I can give the class cup to people, and they don't need to know what my attributes are, how I'm storing them, what I'm doing. They just get this list of public methods, and they're happy. Right? Like with the math library. We don't actually know how the C++ math library works. If you wanted to, you could go look it up if you're bored. We don't really care how it works. We just know, hey, if I want the square root of something, it gives me a square root. Right? Because the math library knows how to do that. Same idea. We're going to write public methods that people can use. So a bunch of methods to get the attributes are our get methods. If these values should change, we need set methods or another way of changing those values. The accessor or mutator, setters and getters. There's a third term, and I can't think of it off the top of my head right now. But we can have a string for get color. So to get the color, so if you wanted to do just a pure H file, right, we could just say, hey, here's the method name, and we could go implement it in a cup CPP file. I'm being lazy. Again, it will make our life easier later. We're just going to write it right here. Okay. Good or bad, it's okay. This is how we're going to do it, and it's okay. Right? You can change your practice later if someone else wants you to do it a different way. Yeah. Yeah, yep, you can have private functions as well, definitely. So like helper functions, things that you want to use inside your code that you don't want to give public access to, definitely. So we're going to return this color. Right? This is the current instance, and then my pointer to color. Don't worry too much about that. We'll get to that later. Nothing new here at the moment, right? Do you need that a little larger? Is that better? Just holler at me. Okay. And we'll write a bunch of get methods here. And that's okay. They're a little boring, but that's okay. So we'll have an int for get, and then I'm a little bit lazy here, so I'm just going to copy paste a bunch of these because the IntelliSense is not great for this one here. This max volume in milliliters, and then an int for get this one, get current contents. Oops, I think I copied too much. It's weird. Current content. The first letter here. And the function name. Yes, it should. Thank you. That's my copy paste. Yep. We'll try and follow some good naming conventions here. Return this current. There we go. And so as you're typing, right, you get this little type ahead. If you like the first suggestion, you just hit tab or enter, and it will fill it in for you. Right? I'm always a fan of shortcuts. Like any good programmer, I'm lazy. Right? I don't want to do more work than I need to. So we've got the first three. We need two booleans. So these ones get funny here. Where like get has lid is kind of funny. Sometimes you say is for booleans instead of gets, but then is has lid also sounds funny. So it's okay. I'm just going to call them gets, and it'll be a little funny, but that's okay. Get has lid returns this has lid, and a boolean for get has handle returns this handle. All right, and two more, the contents and the type of material. String for get contents returns this contents. If you spell better, it works a little easier here. Get type of material made from. There we go. Type of material returns this type of material. All right, so nothing super interesting yet. And actually, we don't even have a way to give any of these values, right? We don't have any set methods, and there's no constructor method, right? So none of these will ever have anything other than the default value. So we need a way to either change these or set them. So when we look at attributes, when we think about attributes here, sometimes they change and sometimes they don't change, right? Whether or not I have a handle, it technically can change if you break the handle off. I have a mug because I really like the mug that the handle broke off of, and I keep the mug because it's a nice big mug and I can fit my ramen noodles in the mug and all that. So that one technically changed, sure. Right? But the type of material it's made from is probably not ever going to change. Right? Once it's a ceramic mug, it's a ceramic mug. Once it's made out of wood and metal, it's probably made out of wood and metal forever. Right? That sort of thing. So if an attribute should change, you want to give access for them to change it. If it should not change, you don't need a public set method. What you would use then is a constructor that accepts the value and sets it once. So if you pass a value into the constructor and there's no way of changing that value again, it's essentially read-only, right? So like you set it once and then it's stuck, you can only ever read it again from there. So the things that should change, color probably doesn't change. I mean, yeah, you could take a marker to it or a Sharpie to it, but let's not get too technical here. The max volume probably will never change, right? Unless you like cut off the top of your mug somehow, but you can have that debate whether or not it's the same mug once you've cut off the top of it again, or if you repair the mug. What is it? There's some guy's boat. I forget the name of him. It's a Greek guy who like kept rebuilding his boat out of the same material again. What?
It's like something like CIS.
CIS? Something like that. Is it really the same boat if you keep rebuilding? That's more philosophical. So the things that should change, we'll add set methods for. The things that shouldn't change, we won't add set methods for. So contents for sure changes. So we can make a void method here, right? We're not going to return any type of value here. This will be set contents. Now, for setting a contents, you have to tell me what the contents are. So I need an argument here of the contents. Some people like this shadowing, where I use the same variable name here as my attribute. I like it. Some people don't like it. I don't know why people don't like it. So I think they're crazy. So I'll say this contents equals the contents. And life is good. You'll notice this one is gray. It matches, like Visual Studio is helping me out here. The gray one matches the gray one for my argument. This arrow matches the white coloring here of my attribute. Okay. Sure. So we can set the contents. We can set the handle, I guess, or maybe we'll just don't worry about that. And we'll say once you've got the handle, we'll pretend you can't break it. Yeah. The set contents here. So the this keyword, so this refers to the current instance that you're working with. So because I have a class for cup, when I go and use it here, I'm going to make instances in memory. I'm going to say, hey, C++, go load one of these in memory. And I can have 50 gazillion different cups in memory. As long as I have memory for it, C++ will let me make as many as I want. Each instance of cup will have its own set of attributes here located somewhere in memory that C++ knows. So it'll have all of these different attributes. So when I say this, it's the current cup I'm working with. So over in my source file, we want to include my cup.h, and then I can make a cup. So this is Eric's mug, right? And then Eric's mug, I can use my dot notation to get all the public methods here, right? Once we talk about pointers next week, we'll look at the other notation, which is, again, there's some distinctions. We'll get to that when we get there. Don't worry too much about it. That makes sense? So this then means, because I'm saying Eric's mug dot, this will be the Eric's mug that's loaded in memory. So I can set contents to, this is coffee right now, and then I can make another mug. So this is my backup mug. And then my backup mug dot set contents is also coffee. Because, let's say Diet Coke. Or Coke Zero, I actually prefer. So if I put this in debug mode, let me make these. I'll declare them both first. And we can go set the contents. And see out Eric's mug.get contents. And an end line. And we'll add some more in here. We'll say Eric's mug has, we can get the contents out. But I want to put a breakpoint in here, right? So to put breakpoints in, you just come over to this gray space next to your lines, and you put the breakpoint in, and then when we run it now, it's going to pause at that spot here, so I can see what's in memory. I can see my variables. So unfortunately, I can't zoom this in, which is a little bit annoying, but I have two different instances in memory here. So I have Eric's mug, and I have the backup mug. And you can see what the values of each of their attributes are. So if I want to step into my set contents here, I have these step into or I have these step over debugger options. So step into will go into the method set contents, and now those go away, and I just have this. This now is that current instance of Eric's mug. So we're in set contents. We can step again. So now I have all my this values. So these are the defaults. So we get true for the booleans, which might be bad defaults, and we'll fix that in just a little bit here. And then we get bad values for the integers. Again, we'll fix that in a little bit here. But we're about to set contents to Coke 0. Right now my contents is Coke 0 here. So this is the object that we used the method on. That's what the this is. So, sorry, a little bit of a long answer, but that's good to show. Okay. So I can set contents, and then we wanted to be able to set probably the current volume. And again, we don't have to have a set method for this. We can have different different ways of interacting here. You get more than just sets and gets with classes here. And that's the fun part of classes when they're actually useful. It's not just to hold a bunch of attributes and set and get them, but we get to define how you interact with these things. So I might have I'm going to make this method return a Boolean here. We'll say this will be fill cup. So if you call fill cup here, and then I want an int, this is, how about milliliters to add. You tell me how much you want to add here as we're filling up the cup. Right, so the idea that I'm pouring my coffee into my mug here, I'm going to say, hey, let's add 250 milliliters. Now, again, it doesn't really work like that in real life because I can't measure 250 milliliters out of my coffee cup or put my coffee pot into my mug. But it's okay. We'll be close. We'll pretend maybe I poured it into a measuring cup first, and then from the measuring cup, I poured it in here because I want to know exactly how much coffee I'm drinking every day, which is a lot. But I don't want to measure that because that's kind of a sad number. But if we wanted to with this cup, we can say, let's add this many. So what we want to do, we want to take our current volume, so this current volume in milliliters, we're going to add to it the milliliters to add. Right? Whatever was in there, we're just pouring in on top. We're filling it up here. Right? But now, we could have done a bad thing. Right? If I wasn't paying attention and one of my kids is like, Dad, 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 and I look over there while I'm pouring, if I pour 350 milliliters in, it doesn't fit. And now I have 100 milliliters of coffee on the ground and I'm going to cry because I spilled my coffee. And that's a really sad time, right? You should not spill your coffee. So if a bad thing happened, the other piece, this other idea of encapsulation and abstraction with object-oriented programming is that my class needs to protect its integrity. The class should not let you put it in a bad state, right? With these public methods, they are going to protect my class and make sure that you can't make the current volume be more than the max volume, right? We will obey the laws of physics here. If the max volume is 250, you're not putting more than 250 milliliters of coffee in because all the extra coffee went on the floor, right? The cup itself will maintain its integrity. So we can check. We can say, hey, if my this dot current is greater than my this dot max volume in milliliters, then a bad thing happened. Again, this is, I'm zoomed in a lot. It would probably just be on one line, but it's okay. You're not too concerned, right? That I've got multiple lines here. So if I have more than my max, well, I can't allow that. I need to change it here. So let's say my current then is equal to the max. And we'll say, hey, we filled it up to the top. You poured in 350, it only fits 250. Well, now your current volume is 250. Congratulations. But then I want to, and again, we'll talk more about exceptions next week, but I need to return some value to tell the person using my cup they did a dumb thing and they spilled some coffee. So I'm going to return false. Hey, this didn't work like you expected. Something happened. Again, we can get to better ways of doing this later, but for now, I'll just return false. If that didn't happen, then I can just return true. Say, yep, everything's good. You wanted to add 100 milliliters? Fantastic. You added 100 milliliters. Life is good. Return true. You're successful. Sure. So filling now, instead of setting the current volume, I'm going to give you a way to add to it. Right? And again, we should also, this idea of being a little bit defensive here, being a defensive coder, is making sure you don't give me bad things, because your users will do the weirdest things when they use your programs. And you say, hey, tell me how much you're going to add. And they're like, oh, I wonder what happens if I give it a negative number. Well, you're not adding, you're subtracting at that point. And then that breaks all of our math here. And if I say I want to subtract 350 milliliters, now I have a negative current volume and we've broken the laws of physics again. Right? And that makes us unhappy. Our code wouldn't care. Sure, my volume's negative 350 now. What? Like, that doesn't work right. So we could also check. So we can say, hey, if my milliliters to add is less than 0, just return false right away. Now, again, some people will say having multiple return statements is ugly. Some people will say having multiple return statements is great. I like the multiple return statements. Some people don't. It's okay. But as soon as you hit a return, your method's done. Your function's done, right? So I don't need this in an else, because if this didn't run, then this code will run here. So the else block would be redundant at this point. There's nothing wrong with having it, but it's just redundant, and you're typing more than you need to. So we're going to do a quick little sanity check, be defensive here. Make sure you give me a valid value. Now, I don't know what the max is. You can have some really big mugs, especially for Slurpee Day, which I think was coming up, right? Weren't they going to have another one? I forget when it was. I thought there was one in September. I was really excited. Where like you can bring any size mug you want, but now they have like a hole it has to fit into, because they got wise to people bringing in their coolers. They're like, yeah, this is my cup, and it's like a 5-gallon cooler. No, so it has to fit in a size hole. But some number of milliliters is like in the multiple thousands here. We're talking about multiple size liter cups here. I don't know what a valid range is, but I know negative is bad. So I might not know what a higher end is for bad, but I know what the low end is for bad. Okay, so that's fine. So I will fill my cup a certain number of milliliters here, right? If it's negative, return false. Otherwise, go and add it. If I did a bad thing and went over the max, stop at the max, right? Or just reset my value. Put it back to max here, because I can't have more than max and tell them they did a bad thing. If I didn't tell them they did a bad thing, it worked out. We return true. Okay, awesome. So we've got fill cup. Now, this only lets me add liquid, so I could also then have a method for drink with an int for milliliters to drink. Right, same idea here. I can have a public method, a way of interacting with this cup that lets you now subtract the contents. Now, again, if you put mac and cheese in your cup and you go to drink it, it might not do what you expect, but that's okay. We'll pretend you can drink mac and cheese out of a cup, and that's your problem if you put mac and cheese in and try and drink it. You can get mac and cheese all over your face. If you open your mouth wide enough, though, it works. You just need to have the right narrow size mug. If you get the really big, like coffee cup size ones, you can't really fit your mouth around the opening, but like a nice little travel mug like this, you can drink mac and cheese, essentially. It just goes right down the gullet. All right, so drink. So same idea here. I want to protect my class here to make sure you don't give me a negative number, which actually would then fill it. Technically, you can do this in real life by spitting into your cup, but that's not really drinking then. You're really filling here. So we'll be technical here and say, even if you spit into the cup, you're technically not drinking. Okay, we'll just pretend backwash doesn't happen, because we're all just happier if we ignore backwash. So if the value is good, then we'll keep on going. So I'll take this current volume, and I'm essentially going to subtract the milliliters to drink. Right? You tell me how much you want to drink, I'll take it away. Now, I don't need to see if we went above max. I need to see if I went below 0. Same idea here, right? If you try to drink 700 milliliters and there's only 250 in here, you're going to be sad and thirsty, right? So we'll check. Hey, if this current volume is less than 0, then we need to set it back to 0, right? Don't let ourselves be in an invalid state. So my public function, my public methods are protecting the integrity of my class. Right? The class should not allow itself to be put in a bad state. That's one of the goals. That's one of the reasons we can write classes, and they're super helpful. Right? You can't do bad things with this class, because we wrote the code. And then we'll return false. Otherwise, we return true. True. Okay? Hopefully nothing new so far, right? A little bit of review. If it feels new, that's okay. We'll get into it. We still don't have a way to set some of these other values yet. Right? We need that constructor method. Yeah.
For the drink method, why do we return false if you drink more than is available? Because it's not like you're not drinking, you're still drinking 8% 0.
So I'm just using the Boolean true false here to say, like, it did what you expected, or it didn't do what you expected. So if you tried to drink too much, you still drank a little, but you didn't get the whole 750 milliliter goal, or whatever it happened to be. So it's just a way of indicating back that it didn't do exactly what they wanted it to do. So it's not ideal, and we'll get to better ways to do this next week, but it's something that we can do here. Okay. All right. Now, we still don't have ways to set the rest of these attributes here, so we need our constructor. Right? That's the last thing we need to add here is our constructor. So our cup, then we need a bunch of different attributes for this. Right? We need the color, we need the max volume. Now, most brand new cups when you buy one at the store don't come with anything in it. Right? I guess if you buy like a Slurpee, you can fill it up for free, but you're technically buying the empty cup and then you're filling it. I don't know. Well, I'm just going to ignore the current volume for now. We'll assume they all start empty, and then you can use fill later on here. So I need a string for the color. I need an int for the max volume in milliliters. I need a boolean for has lid. I need a boolean for has handle. I need we're allowing you to set contents, so we don't need contents here. We need the string for the type of material it's made from. Okay, so I'm going to add a constructor here. So to make a cup, you have to give me these attributes here. As soon as I make a constructor, I no longer have that default constructor here, and now these get upset, right? It says no default constructor exists for class cup. If you don't write one, C++ says, oh sure, I'll give you a default constructor. You get default values, which are garbage. You don't want default values. Like, they are never okay, right? It's always a good practice to write a cup constructor. Okay, and it's even warning me I haven't finished everything yet, which is nice. So it's telling me you did some bad stuff. So now we need to go set the value. So this color equals a color. By this max volume equals the max volume. Max volume. There it goes. By this has lid equals the has lid. By this has handle equals the has handle. Has handle. Oh my goodness, some of these are not typing ahead for me the way I want. And by this type of material made from, it's the type of material made from. Okay, so those are the ones you gave me. Then we're going to default the other attributes. Right, so we're going to say my this current volume is 0. We start empty, and my this contents is just an empty string. Right, there's no contents, right, until you go and fill it and set the contents. So it might be nice to have fill also pass the contents. But that might be a little trickier than we want. Yeah.
This is a question about using this command, right?
Mm-hmm.
So I know the incentive for making these long and detailed names for variables, right? When we're assigning the values to the variables, if we were just put as, like, for example, just like X or Y, we could do that and it'd still work just the same as this, right?
It would, but
what's the incentive for not doing that?
When I come over here and I look at my cup constructor, I see the names of the attributes, and right now I get an int x. I don't know what x is. So if you name it the parameter correctly, when you go and create and call that constructor here, you look at the IntelliSense and it tells you the name of the attribute, or the name of the function. Name of the argument. I got too many words in my head, I'm sorry. So that's why I like using nice names as arguments as well, because it shows up in IntelliSense. So there are other ways you can do it, and you can leave special comments, and you can do all sorts of other stuff for, like, documentation wise to make the stuff show up. But you don't have to if you just name your attributes right. So instead of A, B, C, D, E, F, G, and with a big comment saying A is this, B is this, C, like, just name the variable. Okay, so I'm always going to recommend you use good variable names. Now, if you don't in your code, I will make fun of you, but you'll still get points, right? If your code functions, you will get points from me. I like style, but the goal of the class is, can your code work? Okay, so back when I was an undergrad, I had a class. It was my very first programming class at college. So I had done some programming before because I have an older brother who's 7 years older than I was, and he liked programming. He was into computers, and like that was like, hey, my brother's really cool. I want to do this too. And I like video games. Which turns out the game industry sucks, but that's a whole other story. I was like, okay, let's do this. So in that class, I wrote a program for some assignment. I turned it in. I got points off because I didn't have a comment that was supposed to be required, or I missed something in the required comment. And I swore to myself at that point in time that if I ever had a chance to teach, I would not take points off for comments because the program still worked. And to this day, so many years later, it was 2004 maybe. So 18 years later, I've stuck to that. And I don't require comments for things. Right? If the code works, the code works. Right? If it's ugly, it's ugly. That's okay. You get to be embarrassed about it, but I'm not going to take points off because of ugly code. right? The goal is function here. You can always make it prettier later. I just want to know if you can do the right thing. Okay? Yeah.
This might be a silly question, but as opposed to putting in the constructor, are you able to set some of the default values when you declare the variable?
You should not. You should do it in the constructor because the constructor's job is to set values for the attributes. You can put values, but that's ugly in bad form. So to avoid giving values when you declare them. Yeah.
Okay.
Yeah.
So in C++ specifically, is there any way to have optional parameters without using overloading, like syntactic-wise?
I honestly would have to Google it because I don't remember. I think it's all overloading. I don't think we can say. Can we? Maybe we can. It looks optional.
Oh, okay.
Yeah. So yeah, sometimes we just got to try it. So we'll get to optional parameters. Does this ring any bells for people as being an optional parameter, giving it a default? Okay, cool. So yeah, throw them in if you want. That is way easier than doing the overloaded methods for sure. A lot less typing, but it's essentially doing the exact same thing. It's adding that overload with this one as an option behind the scenes, which is fun. So if you wanted to have one with a current content, current volume, we could add that as an optional parameter, and that might be fun. That could save a little bit of time here. I like that. I like that. Should we do that? Should we add some optional ones here? Why not, right? So we'll have an int for current volume, and then we'll just default it to 0 here. So if you don't tell me what it is, we'll assume it's 0, and then we'll have a string for the actual contents as well. So if you know you're putting that mac and cheese in the cup right away, great. String here, there we go. Otherwise, it'll just be blank. Sorry, I think my sugar's high. This thing beeps me out. Yep. Come on. Why are you telling me then? All right, so we can add some optional parameters if we want. I like that idea. That is a little prettier here. Okay, so now I have ways to give these values here, and I don't have sets for them because they don't change. Right? Once you have the color, once you have the type of material, you're stuck. So now when we call the mug constructor here, notice there's these two other ones. We'll get to these in a little while. Not at the moment here. These copy constructors and references and weird stuff. But now I have to give it, all right, what color is it? So this one is, I don't know, wood pattern. And then the max volume, I think this is about 250 milliliters. It has a lid is true. It does not have a handle is false. It is wood and metal. And then current volume, I'm just going to leave 0. Maybe we'll say what it is. It probably has 250. I've been drinking it, so maybe 150, and then it has coffee. Actually, it's not coffee, it's an Americano, if it matters at all, because that's what I got this morning. Americano is a shot of espresso with hot water added. Very similar in taste to coffee, but you get a little bit more of the espresso flavor out of it. Basically the same thing. It's just fancy. So that's what the coffee shop down the street from me has. All right, so that's my mug here, and then my backup mug here now. Let's see. The color of this one here is styrofoam. I mean, that's really the material it's made out of, but it's also a color, right? Do you think of a color when you think styrofoam, or should I just say white? Maybe white. Max volume, that one probably is maybe 200 milliliters. And then it has a lid is true. It does not have a handle. It is styrofoam, foam, and it's currently empty, and it has nothing in it. So I actually took my backup mug and filled this one up when this one was empty from the drive-in because it started with coffee. It's like a 40-minute drive from my house to get here, depending on traffic. So like the first cup of coffee is gone by the time I get to the door. So you always got to start with the backup one so you can refill. All right, and then we can set some contents if we want, right, and go from there. But now if I take a look and put a breakpoint in here and run this in the debugger, it's going to stop at the constructor, and I can step into the constructor here, and I can see, hey, these are all the values here. So here's my this, nothing currently there. Now we see, right, they're going to start getting set. So these are all the arguments we gave, or parameters that were given. Technically, they're parameters when you define them and arguments when you pass them. I've never understood why people care about the difference, but some people have told me I keep saying the wrong word, so sure. And now these will start to get values, right? We're doing the constructor's job is setting values for all of its attributes. It's fantastic. Right, so still has no contents. Contents is empty. Sorry, again, that's a little small. I don't think there's a way to zoom that in at all. Yeah, I don't remember. They recently added the ability for screen readers to read the stuff. It didn't used to work very well in this variable section for screen readers, but they still haven't figured out zoom yet, which is sad. That's okay. They're working on it. We're trying to make things more accessible. All right, and then we step, now the constructor's done, and now we see my backup mug has a bunch of attributes. I see Eric's mug has a bunch of attributes, and life is good so far. We can continue on, we can set some contents, and we get whatever the contents was here. Okay? That's our class. Right? Public methods, private attributes, protecting the integrity of our class. We've encapsulated all those details around this noun. You get to work with it in an abstract fashion. Right? This idea that you don't need to know the details, you just need to know there's public methods that do what they say they're going to do, just like a library. That's the goal. You're going to write code that is so good and so fantastic, other people are going to want to use it, not just you. Now, that's a lie because this is just your second semester programming and you're the only one who's going to use your code for now. Maybe when we get to the final project, your partner can use your code, but essentially, you're the only one who's going to use it. We're not going to write amazing libraries, but at some point we could, and that's the goal. We want to have those good habits to, so that we're doing the right things here. Snake, yeah, you hate ugly code. I mean, being a neat coder is fantastic. There's whole schools of thought and styles and different ways of writing neat looking code here. And it's a good habit for sure. Like, I don't want you to get into the habit of being lazy and using bad variable names. I'll just make fun of you for it, and then maybe you'll change your habits. But I'm not going to award points because it's pretty, or take away points because it's not pretty. So more about that later. Yeah, so this will be classes, and then exceptions and pointers will be all in the lab next week. So we'll get caught back up on the schedule here because we missed our first week lab because they just don't do labs the first week because I don't know why. So this week you'll do the quick little GitHub exercise and Unix in lab today. It won't be too bad. VI is terrible, but you'll have a chance to have done VI, and then you can all laugh and smile about it when people make jokes about VI being hard to quit and that sort of thing. So then next week we'll do objects, classes, exceptions, and pointers in lab, and then we can be, here's the content for the week, here's the lab on Wednesday. Here's the content for the week, here's the lab on Wednesday. Yeah. 6 p.m. Yeah, it's a weird schedule. I didn't make the schedule, I'm sorry. I don't know why. So 7:45 p.m. or basically when you're done, right? Like you shouldn't have to sit there if you're done. But like we've got the hour 45. We designed the assignments to be doable in that amount of time, that sort of thing. And then you can meet Mr. Dia, talk with him about his expectations. So no, so it's in a computer lab where you actually have computers to work on. Yeah.
So how do labs work specifically with programming? Is it literally just walk in, code in?
You can talk to Mr. Dia about his expectations. When I run them, yes. I say, here's what you're going to work on, and then I have a chance to actually walk around the room and help with things. So Mr. Dia can walk around the room and help with things in the lab because you all have computers or bring your laptops. For the Unix lab, you can install the software on your computer if you want. If you just want to use the college computers because you don't want to install stuff on your computer, that's fine. But you're at least going to put Visual Studio on your computer or whatever you weird people who use Macs use. I mean that in a nice way. I apologize. I just don't like Macs. It's just a personal bias. Apologies. Okay. Yeah. No. So we're going to start Project Zero next week, and we'll have 2 weeks for it. So every project we'll have 2 weeks for. So we needed to get enough material in before we can start a large enough project. So next week we'll talk about Project Zero, and then every 2 weeks we'll have a project up through the group project. So the Lab Zero will be about GitHub and Unix that we talked about last week because our schedule got funny. And then starting next week, the labs will be about stuff that we've talked about that week and objects and classes next week, but then we'll be back in sync. So we'll do something Monday, Wednesday for lecture time, and you'll practice in the lab that Wednesday. We'll do new stuff Monday, Wednesday, lecture time, you'll practice it that Wednesday. So it's only these first 2 weeks that are funny because we didn't have the lab the first week. Yep. Okay. So other things with classes now, right? We have all this code here for drinking and for filling, and we haven't tried any of it yet here. So I feel like it should work because I know what it was supposed to do, right? Just like when you write an English paper, you know what you meant to say. So obviously you got it out in the right words the very first time. You don't need to proofread it, right? That's a joke. I'm not very funny, I apologize, but I try. So how do we make sure that our code does what it's supposed to do? Yeah, we test it. Fantastic. That's right. Now, let me ask you another rhetorical question then. Who is better at figuring out if a value matches what you expect it to be? Are people good at that, or are computers good at that? Who's better at like taking two values and saying, do these values match? People or computers?
Could be better.
Computers. Computers are better at it, and they don't get tired of it, right? If you're working on your code and you are spending lots of time on it and running it and testing it and running and testing it and running and testing it, you're likely to make a mistake. Let's be honest here. And that happens. Mistakes happen all the time. That's a whole other interesting philosophical question here. The tech industry generally is pretty forgiving about mistakes. And we're like, oh, sure, it was a teaching opportunity here. So there was a whole thread on Twitter where people are like, oh, yeah, I made this mistake and it cost the company 15 grand. And they said, please don't do it again. I'm glad you learned your lesson. And then there's a thread replies from people who work retail, and they said my cash register was $1 short and they made me pay it out of my own pocket. They're like, what is going on here? Like, why do we treat these people so badly? Like, we don't ask tech people to pay 15 grand out of their pocket. We're like, yeah, please don't do that again, right? We should fix our processes. We could make it so this shouldn't happen. And in retail, we're like, no, you're stupid. You suck. Pay us back. It's awful. Like, it's just a terrible industry. My son's 14 now and he wants to get a job. I'm like, the only jobs I'm going to hire you are terrible. I don't want you to go do that. He's like, but I want to make more money. Like, you really don't want to go work these jobs. And I don't know, is that we're awfully spoiled. I suppose that I can tell my kid, don't go work a job, don't go work a terrible job. But his friend from church got a job and she got yelled at the drive-through McDonald's and get like because she gave the wrong thing. And she wasn't even the one that bagged it. She's like, they gave me the bag to give to you and it had the wrong contents. I'm sorry. Why are you yelling at me? I'm a 14-year-old kid. Like, people are just messed up. I don't get it. But we want to make sure that they do the right thing here. So we're going to test our code. To make the computer test it, turns out there's ways to do that because Visual Studio and other development environments are written by developers for developers, and developers know that this is the sort of thing we want to do here. So I'm going to go and add a test project. There are ways to do this in Macland. I don't remember all of them. So I'll show you the cheesy way first, I suppose. So the really ugly, cheesy way here to do that in non-Visual Studio land, or I'm sure there's testing libraries. I could look them up. I just haven't yet because I don't like Macs. I apologize. I will do that before next week. Is we know what we expect to have, and we will compare those values here. So I can say, hey, I'm going to have an int for an expected current volume is going to be, let's see. So if I want to fill up my styrofoam cup, it should stop at 200. Wait, 200. Okay, and I can take my backup mug and I can call fill, and I'm going to fill it with like 10,000 with some really big number here. We don't really care. And I'll have a Boolean for the result. Result is the fill cup. So if I fill it with 10,000, I know it should stop at 200 because we told it 200 was the max. And I know that the result should be false because we wrote the code to say if you did a bad thing, you get false back. Right? These are things that I expect. All right, maybe we should say expected result. This expected result. All right, so we have expected values, and then we're going to get actual values. Okay? I'm sorry, this is the actual result. My bad. Actual result here. So my Boolean for the expected result is false. Right? I think it should be false. Here, let's see what it actually is when I call the code. Yep. Expected. So typos happen a lot. I'm going to do it a lot. Please call it out. I'm happy to make those changes here. Thankfully, C++ doesn't judge me. So you're welcome to. I have a. That's okay. I've been to a lot of school, but spelling was not my strong suit. So, all right, and then we'll have a int for the actual current volume. Here is my backup mug.get current volume. Okay, then we need to compare them. So to compare them, we have a couple options here. And this is why doing it the right way is better. This is the ugly way, but it'll still work here. So we can say, hey, if the expected result does not equal the actual result, then we can see out error or something didn't match. Do something better here, but we'll get there. This is the cheap and easy one with the result. And then we can say, hey, if my expected contents current volume does not equal the actual current volume, we can see out volume doesn't match expected, something like that. So we're making the computer compare them for us. And if I run it now, there shouldn't be any. It's in debug mode. We'll just continue here and continue again. Sorry, I'll take the breakpoints out in a second. It didn't pause for me. One second. One more time. There we go. We didn't get any of those errors. So by not seeing the errors, I know life is good. Again, it's still a little failable. It's not the best practice, best habit, best way of doing it. But that's probably the only way you've been able to test your stuff up to now, right? You give it something and you see if it spits back out what you expect, right? That's the only way we had to do this. And that's a good habit. You want to try your code and make sure it does what you expect it to do. But I want to show you the better way. So I'm going to go to my solution and I'm going to add a new project. Now in here I have a test project. So I want a native unit test project that writes C++ unit tests using the native Microsoft C++ unit test framework. Again, not available on Macland. I'll figure something out for you, or you can just do it this poor man's way here. It'll work eventually. Okay, so the unit test project here, again, you can name them if you want. I don't really care. I'm just going to leave it unit test 1 because defaults are easy for me. Excuse me, allergies are bothering me here. So you get a bunch of code that does some funny looking stuff here. Don't worry too much about it. What we want to do now here is we want to use the cup H file. And this is the reason I put all the code in the H file, because otherwise you can't just include the H file and have it work. If you have just your headers in the H file and you have actual code in the CPP file, you have to do a bunch of other steps, which I tried to show people a couple of years ago and their eyes just like rolled back into their head. They're like, okay, this is dumb. We'll just put it in the H file because life is easy. So I can include. Now, if I just put in quotes here, though, there is no file for cup, because if you see the path here, it's real small, but it's unit test 1. So it's inside the unit test folder currently because it's a different project. And there's lots of good reasons to do this too. We'll talk about in just a little bit here. So if I want to go up a directory, remember back to our Unix lab here, ... goes up a directory. So ... then I can go into the object and classes folder, then I can get the cup H file. So hey, it's handy that we talked about ... being up a directory. You don't have to memorize it. It's okay. Don't worry about it. We're saying go find this H file over here. And remember, when you do an include, it basically copy pastes that entire file right into this line. So again, if you're doing tons of includes all sorts of different places, you don't have that pragma once, it does weird stuff. But we have the pragma once command, and it says, okay, sure, I'll just load it one time. Life is good. No biggie. So now I have the cup file. So then what I'm going to do here is I'm going to write these test methods. Test methods allow me to make Visual Studio do what we did over here and compare results. Now, I'm fond of this. It's known as the AAA convention. So it's just a way of making tests. It doesn't mean this is the only way you can do them, but it's a relatively common way of making tests in the industry. And if everyone does it the same way, it just makes life easy for us. So the first A is for arrange. So we're going to set up the variables we need to test. So all of the things that I expect to get are going to be arranged. Okay, and then we're going to act. We're going to call the code. We are testing and get results. And then we're going to assert. Did we get what we expected? That's all it is. So it's just a way of organizing your code here. There are tons of other ways of writing tests, and they all work, but this is one way of setting them all up here. So we'll do that exact same thing here. So I'll have an int for the expected volume. That'll be 200. And I'll have an int for a Boolean for the expected result. We said it was going to be false. Okay, and then some people will put the constructor in act, but really we're not testing if the constructor works. We're testing if the fill method works here. So actually I should change this here. So test method, this is fill over max. Right? I'm going to be nice and descriptive about what I'm testing here. Excuse me. So I'm going to just put my cup here in a range, because to do my testing, if I'm testing the fill method, I need to have a cup to call it on. So I'll have a cup for cup, and then I don't care about most of these things. So I don't care what the color is. I do care what the max is. So for the max, I'm going to put that as the expected volume. Because that should be the max here. Volume, come on, type ahead. Why are you not working for me? That's okay. Has a lid. I don't care what these values are. I'm not testing these right now. Material doesn't matter. And then I'm just going to leave the defaults there. So 0 contents, sure. It's all well and good. So now I have a cup I can test with. So then for acting here, I'm going to have my Boolean for my actual result is equal to my cup.fill, and I'm going to give it some big number here. Or what I could even do here is take my expected value, expected volume, like times 2. Right? That way it's always going to be more than, so if I ever change the volume and say, hey, let's see, can I do like a 2 million milliliter cup? And I had put in 10,000, it wouldn't give me back a false. So I'm always going to do double whatever my max was, just to make sure. I could do like +1, or we got lots of options. So any value that I know will make it false. Okay, so we'll try fill, and then we'll get an int for the actual volume. Here is my cup.get current volume. Okay, so same thing so far, but now when we assert, it's assert colon is equal, or r equal. Oh my goodness, r equal. There we go. There's all sorts of different things you can use here in the assert library. So assert colon, you get a bunch here. That stars the most common ones, right? Things that we generally look at. R equal, is null, is true, is not null. Got all sorts of fun options here. But R equal, then we want to check then my expected volume, and the actual volume. And the other really cool thing you can do is you can give it some sort of message to spit out if it fails. Again, I'm not going to worry about that at the moment here, but the library is really handy. And then we can also assert is true then if we wanted, or is false if we wanted. Instead of even like having an expected result of saying does false equal false, we could do that, or I could just say, hey, my actual result here then should be false. This saves a little bit of typing here, and I don't need to use the expected result. Then to say, hey, it should be false, right? That works out relatively well. So then what I can do now is I can run my tests. Is it this one? Nope. That's not what I wanted. Test, that's right, from the test menu here. I'll go to my test explorer. And in the test explorer, oh, that should be docked here. That's weird. Let's put it like, no, come on. This one, no, I want it where toolbox is. There we go. Okay, so I want the test explorer. I like having it on the left-hand side. Visual Studio is super flexible if you haven't noticed that. You can put your windows anywhere you like them. Usually it's on the left-hand side, so I like to leave things where they usually are, because otherwise I get confused. So right now it says, build your solution, discover all available tests. Click run all to build. Okay, so we'll go to the build menu and build solution. It goes and builds the solution. Now it shows there's some tests. So I can take a look at my unit tests, take a look at unit tests. It's the unit test project, the unit test class. Don't worry about it. But you hit run all. There's the run or run all. Run all. And now what I'm going to get a green check or red X, which is awesome. So if I get a green check, it means it passed. If I get a red X, it means it failed. So if I go back to my source, my cup class here, and oh no, let's just change this one here. So let's go to our unit test. Let's make it fail for a minute here for fun. So if I fill it with like 100, so I'm going to intentionally make this test fail here. Now when I run my test, I get a big red X here, and you can take a look at the message down here, and it says, hey, test method fill over max failed. So this is why naming your methods here, giving it a nice name here is useful, so I can see right away, okay, this is what failed here. The assert failed. Expected 200, actual was 100. So if you give it the expected first and the actual second, it tells you here's the expected, here's the actual. Right? This is why we kind of follow that convention here. So I thought it was supposed to be 200. I only got back a 100 here. Something went wrong, and you can actually click on this stack trace. It'll take you right to that line if you want, which is fun. So you went right to, actually it wasn't line 27. It was line 20. It was line 26. Okay, sure. I don't know why that's the wrong line number, but that's okay. So we can see that test failed. The other really cool thing you can do here is you can put a breakpoint in your unit test, and you can debug your unit tests. So I can debug my test, and then I can get in debug mode what's happening in my unit tests. right? This way I don't need to necessarily write all this stuff in my source file here. I just need the unit test to go and do that. The other cool thing that happens here, so not only is the computer better at this than humans are, right, is that once we have code for this, we can hook it up so that the tests run every time we make changes. So one of the ideas with software is that it costs a lot of money to write. Right? Software engineers are not cheap in the grand scheme of things. So software is relatively expensive to get software written for you as a company. So you want to get value out of your software. Right? And when companies make business decisions, right, we're going to invest a certain amount of money to get some software, they're going to want to keep using that software for a while to get a good return on investment. Right? If you spend a bunch of money to write the software, you pay someone for a month of their time to write some software, figure out what their salary divided by that, all that good financial stuff. We want to get that money back. So my software should last a long time. There's this idea of a software, software development lifecycle. You can learn about that in one of your software engineering classes. But the bulk of software existence is not in you designing it and writing it and testing it. The bulk of a software's existence is it being actually used by people. That's like it's in production, it's in use. You want that to be as long as possible because the longer you use the software, the more you're getting your value out of what you paid to do that little bit of design, development, and testing. Right? So we want our software to be around for a long time, but turns out things change in the world. So sometimes we have to go and change our software. We have to update it. We don't need to write something from scratch. We just need to go take our piece of software and go and update it. So if I need to go update my software and I make changes here, it's possible that we change something that some other piece of code had a different expectation that it would do something. And I know something is a really vague term here, but when I have unit tests, if I go and make a change and my unit tests pass, I can feel pretty good that the core functionality is still there. I haven't broken anything by my changes. If you go in and you change something and your unit tests start failing, some piece of behavior that was expected now has changed, and we're likely to cause problems if we didn't mean to do that. And again, it's really hard to give a good examples at the small scale, but we want to have tests here that the computer can run over and over and over again to make sure that as we make changes to our software, what we expected to have happen still happens. And the next thing we can do with that is once we hook our code into source control tools like GitHub, you can do this thing that's called continuous integration testing. Every time your code changes, you can go and run tests. So if you look up GitHub, there's a .NET. There's a bunch of examples out there, but they've got projects here, and any of their projects will have, I don't know if these ones will actually have tests or not. Yeah, these ones might not. I'll find some for next week for you here, but you can see that they will run tests every time the code changes. So you can hook that in for continuous integration testing. Then, if your tests pass automatically, you can go to the next phase of continuous deployment. So depending on what your product is, you can say, anytime my code changes, if the tests pass, go push the code out to production, go and update my live system. Because I know all the tests pass, I have a good feeling that this works. So by having automated testing, we can have this cycle where I can make a change and get my production code updated like that, or within a matter of minutes here. And it doesn't work for everybody, and depending on what you're writing, it works out well. So I have a friend at Khan Academy. They can make a change to the production website at Khan Academy in a matter of minutes after they change their code. And that's the idea. So we can rapidly iterate and change and evolve our product in a really fast and efficient manner. All right, folks, I'll see you on Monday. Have fun at lab.